A molecule trapped on a textbook page is no more alive than a static image of a lion in a zoo. That's the core challenge Ian Gould, the president's professor at Arizona State University's School of Molecular Sciences, has been tackling for years. Traditional chemistry education, he argues, leaves students with fragmented understanding, because molecules aren't just diagrams. They're dynamic, interacting entities that shape everything from human health to environmental crises. But here's where it gets controversial. Most chemistry courses still rely on outdated methods that fail to show students why this matters. The result? Critical misconceptions about chemical processes that could haunt students long after they've closed their textbooks. And this is the part most people miss. The disconnect isn't just academic. It's a barrier to seeing how chemistry can solve real-world problems like pollution, disease, or even space exploration. But what if learning chemistry felt like stepping into a story where students had to solve these problems to move forward? That's exactly what ASU is testing this fall with its VR-based chemistry curriculum, Dreamscape Learn. Starting with CHM 113 and CHM 114, students will trade static diagrams for immersive narratives. Imagine piloting a spacecraft into the Amazon rainforest to retrieve a cyberweapon from a burned-out tech site, or investigating a Himalayan village where a chemical pollutant is poisoning the water supply. These aren't just games. They're carefully designed labs where students apply chemistry principles to unravel mysteries. Christian Bueno, an electrical engineering major, explains how it works. You're using X-ray fluorescence to analyze a crime scene's elemental composition. Suddenly, abstract concepts become tools for solving real problems. Gabriel Lariosa, a neuroscience and psychology student, adds, VR shows you why converting grams to moles isn't just a math trick. It's how you tackle a crisis in the real world. The curriculum pairs 9 VR modules with 9 hands-on lab experiments, each linked by a cohesive story. Students track chemical interactions in 3D environments, use virtual instruments that mirror cutting-edge tech, and see how energy flows in molecular systems. But here's a question to spark debate. Is this the future of STEM education, or a distraction from foundational skills? Critics might argue that VR could oversimplify complex concepts, yet ASU's data tells a different story. A 2025 study of NeoBio, the university's first VR curriculum, showed students from all backgrounds scoring 90% plus on lab assignments. More importantly, they stayed in STEM majors and outperformed peers in advanced courses like genetics. This isn't just about grades. It's about inclusion. Gould points out the 1950s-era science curricula were designed for a narrow, elite group. Today's students, especially those who feel unwelcome in traditional STEM spaces, need to see themselves as scientists. Dreamscape Learn isn't just tech, says Era Austin, a clinical associate professor involved in the project. It's a bridge to places we'll never physically visit, like molecular worlds where students become problem solvers. The goal? To empower a new generation of innovators who can tackle global challenges. As Austin puts it, the old curriculum made science harder. Dreamscape makes it accessible, and that's on us, not the students, to change. So what do you think? Is VR the key to democratizing science education? Or does it risk losing the rigor that makes chemistry a foundational discipline? Share your thoughts below. We're curious to hear if you agree or if you see a different path forward.